Hey, Dustin Vanoy here. Thanks for joining for another Apache Spark Data Kickstart, this time focused on some common, though somewhat basic patterns for reading and writing data with Apache Spark. So every Spark pipeline involves reading data from a data source or a table. For data engineers, we usually end our pipelines by writing that data back out after it's been transformed, sometimes joined, other types of things that will add value to the data in most cases. In this video, we'll walk through some of the most common patterns for this reading and writing with Apache Spark, including reading from various cloud providers and just a little bit about the authentication, though that can vary based on environment. We'll save some of the more advanced like Delta Lake type topics for another video. We'll focus on some basics and make sure you see quite a few different options for reading data. Let's get started. So here I have a Databricks Community Edition notebook called Spark Kickstart Read Patterns. You can go find this at the GitHub that I've been using for this course. Check the description for links for that and other things. First, I want to call out that there's quite a few protocols that can be used with Apache Spark. Whether or not all of these will work natively from the Community Edition of Databricks, I can't confirm, but I've used these different types of protocols that are listed here in this cell since I started working with Spark, and I've worked in quite a few different environments. So we'll call out a few of them as we go. For starters, though, when I get to writing, you'll see me use the Databricks file system a lot. It's just sort of a built-in system to write to. It's not where I would typically do any real production saving of data, but it can be used for temporary storage and for things like saving your code to work within the Databricks environment. First, let's look at reading from a comma-separated value file, which is normally called CSV for short. This is a file format that's been very popular since I started my career and continues to have a presence. So in the format CSV, you end up with a value for each column, which is separated by a comma or some other type of separator. Sometimes a tab or a pipe character is used. Each row is going to be its own line, and sometimes we use a custom character as a row delimiter also, rather than just the typical new line character. So here's our CSV cell, where we're going to use spark.read, which is going to be the common pattern for any Spark reads. And we have a set of options we can choose from. I'm going to focus on two of the more common ones that I work with. And first, schema is a way to make sure that we interpret the schema automatically as we read in the data, and it saves us the time of supplying it in advance. Sometimes, though, the data types could be incorrect. We also don't really have a check then to make sure that our CSV matches the expected schema. A header true means that there's going to be the first row in the file has column names, and those column names will be used for the data frame rather than the defaults, which are like _1 or col1, depending on how you're doing things. And then in the .csv section of this call is where we actually supply the path. You could also do format CSV and then a .load as the additional piece to load up that data and then supply the path there. Okay, once we have set that up, we can read and display it, which I've done with the display command here. I won't go ahead and rerun each of these. You can actually see, since I'm working with small files, the time will be pretty short, but we'll save time from running each of these and just talk through each command as we go. So now another common format, especially for that like first ingestion of data that's been landed by other systems, is JSON. JSON is still really popular, partly because you can store pretty complex nested data here, but a human can actually open the file and read it and make some sense of it. Our data frame is going to be JSON df. Every time you'll see me have a variable name, sometimes I'll reuse them. We're going to use the spark.read command yet again, and here I'm going to go ahead and infer the schema. This is a bit more risky with, in my opinion, more risky with JSON than it is with CSV, because JSON doesn't always, if an object's null, if a value is null within there, it may leave that attribute out of an individual JSON object. So point is that if the first set of files that get read don't have all of the possible fields, you may end up lacking some things in your schema. It also could get it incorrect or have trouble with data types, but it does a pretty good job, honestly. All right, beyond that, we will read this with just .json. Again, I could have done .format JSON and then called a load command on this. And so here I actually read from S3. So I switched that protocol from a built-in Databricks dataset to be S3. However, this is a public one, so you could actually go run this same statement on your end and you should have access to it. And so this went and used some different types of source drivers to read the data, even though the command looks really similar in Spark. And then of course I displayed the data, which I'll do each time. You'll see a pattern. A lot of this is going to look fairly similar, and we'll start talking about cloud providers a little bit more as we go. Next, let's read from Parquet. This format's popular for analytics because it gives good read performance by using columnar storage and good compression techniques, as well as storing the schema and some metadata along with the files. The format's been a really good answer for many years now, though we do have newer formats that have been based to add another layer on top of Parquet, such as the Delta Lake format that I'll show as well. So with Delta Lake format, with some others like Iceberg, it still uses Parquet under the covers, but it adds additional capabilities. With Delta Lake, that's a transaction log and some different API commands for optimizations that will benefit you beyond what Parquet alone will do. So let's take a look at how easy it is to switch to reading from a Delta Lake table once we're done reading from Parquet. Here is an example of reading Parquet. We do a spark.read.parquet, and then we give it a path. In this case, I've read from, this is a little bit older protocol. It can still be used though, for Azure Blob Storage. And so I've used the Azure Blob Storage protocol and read some public data that is stored in a public account called Azure Open Data Storage. So this command also should work from your environment if you wanted to go try to run this on your own. When we get into doing things with our private environments within Azure, we then have to start providing credentials. And I'll use a similar type of thing with Google Cloud as well. But let's focus a little bit on the Azure credentials. I won't go too in depth here, but I just want to give you some kind of high level before I start reading from it. Okay, so this function is to authenticate to Azure Data Lake Storage. It's also what I would use to connect to Microsoft OneLake. So within it, I'm going to set some Spark configurations. These could be set at a cluster level when you start up the cluster. I choose typically to start them up within my application or to set them within my application. In this case, I've got some built-in values that you'd want to use if you're doing service principal. In the description, I'll have a link for some of your different options when connecting if you choose not to go the service principal route. But you will want to make sure certain things like possibly your client ID, definitely your client secret, are not visible in your code. Typically, we would use Databricks secrets for that. In this case, I will use environment variables and just be very careful to not let you see the values of those environment variables, though they are a bit easier to access if you store it as a Databricks secret. And then you'll need to find your directory here as well. So consult the documentation on where to map all these to. I think I've done a video on this a while back, quite a while back, and it probably hasn't changed all that much. But that's kind of the idea, is that you need to set these with the appropriate values. Looking forward at how we would do this in a non-community edition environment, I would usually set up a secret scope by using the Databricks command line. You can do this through CI/CD, but usually the command line is involved in some way. I would specify my account and my secret scope, and then go look up secrets that I've put in that secret scope using dbutils. Okay, so you've probably seen this if you watch my other videos. You'll continue to see that anytime I'm showing Databricks work, but you may not be running from Databricks. That's completely fine. If you store these as environment variables to make them, a bit more hidden and try and lock them down a little bit, make sure they're not in your code, then you can read those in Python by importing the OS library and doing os.getinv, and then passing your environment variable name. In addition, I've just set the client ID here because I'm not as concerned about anyone seeing that. Really, your directory ID could be visible here as well. I chose to hide that just to keep more of my information private. This client I'm going to delete pretty soon anyway, so I wasn't too worried about that. And then finally, with those values, you'll call this authenticate command and set everything up. Now that I'm authenticated, I don't have to pass credentials every time I make a read. So my Parquet read with this private storage account location is spark.read.parquet. With Azure Data Lake Storage, regardless of where you call it from, the protocol is this ABFSS, and then you're going to do the container name, @, and then your storage account name. And then there's a common DFS core windows.net that you'll use for every storage account that you're doing ADLS reads from. After that starts to become under your container, the path to the actual data. Okay, Another thing to note when you're working with Parquet, a lot of times I don't have to specify a lot of information on the reads. A little bit more might go into the writes, but it's going to interpret partitions for you. At least Databricks does a great job of this. I think most Spark environments these days will interpret whether or not there's partition fields and make those available and leverage those fairly well, though the results can vary depending on how you write your queries. Okay, moving on to Delta format. Really, a lot of times when I'm talking about working with Apache Spark these days, I start with the Delta format because once you've ingested some data, maybe you read it in from an S3 bucket that has a bunch of JSON data, I'd recommend save it as Delta Lake format for quite a few reasons that we can cover another time, and I've probably talked a little bit about in this series already. So when we're saving as Delta, it's still pretty straightforward. I do a spark.read format of Delta, and I call the load command. And so this is a different location. Data is stored a little bit differently. There's still some Parquet under the hood, but I have a Delta log that's within this yellow Delta directory to tell it which files are appropriate to use and let me do some really cool things like run optimize commands to speed up my reads in the future. Okay, so we read Delta Lake automatically using those storage credentials we set up a few cells above, and we're able to read from my private storage account. Now, when OneLake, which is now in public preview by Microsoft, continues to evolve, this might change. So I'm not going to spend a lot of time here. But when you're reading from OneLake, there'll be a similar path to how you would do ADLS. Instead of the container name I used before, you would use your workspace ID. And then for the storage account, it looks like it's always going to be OneLake as far as I've seen so far. And then that dfs.fabric is a little bit different than what you've seen. I haven't actually tested this command yet. This comes from a blog post by a colleague of mine. Abe has kind of walked through what he saw as the way to set this up using service credentials. There's also official documentation that talk about using ADLS pass-through, which I can link both of those in the description here. All right, moving on to S3. If we actually need to set some credentials, I actually haven't used option 2 or 3 that I'm showing here in quite a while, except for to create this video, because usually you can set up an instance profile. An instance profile would have access to certain S3 locations, and then you can just, from the cluster you're running, that runs with a certain instance profile already included, and that instance profile will give you all the access without you having to know much about it besides which cluster has access to the data that you need. So plenty of documentation on that. I don't need to walk you through that setup. If you're not using an instance profile though, one of the easiest ways if you're working with Databricks, I'm not sure where else this is supported though, is to set a few environment variables, AWS secret access key and AWS key ID. Typically, like I was saying earlier, you would set those from a secret scope. This is the syntax you would use to actually put that into your cluster configuration and set it automatically from a secret scope when you start up your Databricks cluster. In addition, something I've used quite a bit in the past, not anytime recently to confirm that all these things work smoothly, is the S3A provider, which has a few different things that you would set. The same way we did Spark configurations above, you would do that here. If you are doing it in line the way I did ADLS authenticate, you probably don't need the spark.hadoop, but if you're passing it through it like a command line Spark submit type of call, I think you need Spark Hadoop still. So that's another option, but I would prefer one of these two other options if you have them. All right, so I've got my option 2 set, my secret access key and my key ID, and I went ahead and ran against my private S3 location, and I can see that it read there as well. All right, and then it's Parquet. So same thing, I just changed what protocol I'm using and made sure the credentials are there. Let's take a look now at Google Cloud Storage. For this one, I went ahead and set up my authentication in a similar way to ADLS. So I created a function, passing in separate values that are specific to Google Cloud. And then I'm setting several different Spark configurations here. Again, the spark.hadoop prefix would be added if I'm setting these through like a command line or something. But when I set it here in the notebook, I don't need to put that in there. All right. And so The email is a service account email within Google Cloud. Your project ID is going to be the same for a lot of work within the same Google Cloud project. And then you'll have a very intense private key that you probably will want to store as a secret one way or another and pull it in from there when you're setting it. And then private key ID is just a GUID that you'll find. So if I'm reading from environment variables, this is how it would look like. Full disclosure, I didn't actually do my private key from an environment variable. This is just kind of a way to show that it was set one way or another. And then once I've got that, I call my authenticate, and I can move on to reading from Parquet. Same look and feel as everything else, except I'm using the GS protocol here instead of S3 or the AWS S3. So we can read from different clouds using Databricks. You can read from different clouds using Apache Spark without Databricks. You may have to add a few jars to your setup depending on where you're running things. Now let's take a look at databases. I'm going to show a basic JDBC, and in this case, I'll be using an Azure SQL Database. But really, this type of thing is similar, other than the URL is usually what will change, depending on if you're using Postgres, MySQL, then this URL is going to look a little different, and you might have to build up the options slightly different, but it should be pretty similar. So I've gone ahead and set a lot of the information right here in line, and the password I've stored as an environment variable, retrieved it with os.getinv yet again. I'm going to read from a table called users, and my format's going to be JDBC. So this is the generic driver, the generic format really, that I can use with quite a few different database types that I'm going to read from. I'll set my connection string or my URL. I'll give it the table, the user, and the password, and call load. Remember Spark's lazy evaluating? We talked about this in an earlier session during this series. And so until I call this display df, nothing's really going on behind the scenes, at least not too much. Display df is going to retrieve the top part of my data set. We can see it retrieve quite a few rows here. Now, when working with SQL Server or Azure SQL databases, there is a driver that performs faster. It's not fully supported on the newest versions of Databricks runtime and the newest versions of Spark. So if you're on Spark 3.1, it should work. I believe 3.2, it may not be fully supported yet, and definitely 3.3 and above. I've seen some things, so I don't have a right example working with this one because of the version of Spark I'm using. But let's say you're on an older version of Spark, or you find an updated version of this library by the time you see this video. The main difference here is that we would be changing the format from the generic JDBC to be this specific library. And in my note above, I call out that you would need to install this on your Databricks cluster. Let me show real quick that when I talk about installing libraries, the way that looks is you come to the compute, pick your cluster. From your cluster page, you can choose libraries, and then you would do install new. In this case, I used Maven, and I basically pasted in the exact coordinates that I mentioned below. You can also do something like a search on here and try and find packages that way. So I pasted the coordinates that I show below right here and hit install, and that's how I got that going. Notice I did a version of Spark XML, which I'll show the code for in a moment too. Back to our notebook. My read looks really similar. My options look very similar. I call load, and I've got data. Potentially a little bit faster, though honestly with this example it won't make a bit of difference. And I'm trying to remember how much of the performance gains I saw on the read. I think on write is where I saw much bigger performance gains. But again, this was using Spark 3.1 when this was fully supported. I'm not sure what you'll find if you're on a newer version of Spark. Okay, another common place for writing data to serve as kind of the final serving layer in your architecture is Snowflake. So here's an example of how we would do that. I've got, again, these would normally come from secrets, but instead I'm using environment variables in this os.getinv to get the Snowflake URL, password. You'll need to know a database name, a schema, and a cluster to connect to. The cluster is pretty important because your cluster can be different sizes. They're going to, it's actually called a warehouse. Let me be clear on that. So the warehouse is going to be different sizes. You can, if it's not running, it'll spin it up for you. So you may want to take advantage of one that's going to be kind of the main ad hoc place you do. So you're not always spinning up a separate warehouse for your Spark workloads. It just depends on how you set up your kind of ETL processes or your applications that you're using. So in this case, I'm reading back from Snowflake. Not the most common thing to do on a day-to-day basis, but it certainly is something that gets done, especially by like data scientists that need to pull that data out of Snowflake back into Spark to do training and scoring of data. All right, so with this, we have a set of options. I've set it up as a Python dictionary this time. You could kind of put each one as an option down here in the Spark read if you choose to. And then I use this nice command of .options with an S on it. And then this asterisk will basically unpack all these key value pairs as separate options. So that's one way to do when you have a bunch of options that you need to use together. All right, and then we set the table name and we call load. And that went ahead and read in that trips dev data. So that's Snowflake. There's quite a few other types of formats you can use. I'm going to give the last one because I unfortunately have had to do this. So I'm going to show you at least a hint at how to do it. You're definitely going to need to look at what this row tag's about and root tag's about if you get stuck in this world of reading in XML data still. But when you do need to read it in, there's a special library from Databricks that you can use. And again, it's going to look like spark.read, but this time your format's XML. And there's a few specific options you'll want to understand and make use of for your XML data sets. And then you can infer schema though, which is nice because the schema is, kind of in there for you to an extent with XML. And then you load up the data. I don't actually have this file on this community edition cluster. So you might have to, you have to get that XML data into a location. I actually don't even know. Anyway, you might need to do this to read from DBFS. You might want to switch it to something like this with a modern cluster and a modern DBR version. Finally, I'm going to show you how we deal with schemas in Spark. This is just an intro to schemas because I don't want to drag this out any longer than I already have. So with schemas, we are going to have a couple of options. One is if I've already got a data frame. This is my Delta data frame I created by reading off of Azure Data Lake storage earlier. I can call dataframe.schema to set a schema variable that knows the schema now. So obviously this is if I read the data, infer the schema, I can then save that schema and use it for additional read commands or other types of things I do in Spark. So here I've printed it so you can see that a Spark schema is really made up of a struct type class, which is a collection. This is a list of Python struct fields, and each field has some definition. I basically took what I printed and kind of cleaned it up and made it as if I'm defining it manually without knowing the schema from inferring it. And this is what that could look like. So I create a struct type. There are some other helpers to do like a struct type.add field. If you're in Scala, you have a few other kind of neat short ways to build up the schema, but this is kind of your basic fully written out schema here in Spark. We're going to use column names as the first parameter for each field. Some sort of Spark data type is the second parameter. And then this true is about whether or not it's a nullable field. So all of these fields are allowed to be null in this case. So I've done all this with something like a JSON file. I believe with many types of file formats, if there's certain fields I don't want to read in for whatever reason, I could leave them off just by getting them out of the schema, and it should work just fine on reading that data and just ignore the columns that you left out. That may not work with every type of format. With something like JSON or Parquet, I believe that will work out fine for you though. But here's an example of me passing in the schema. Earlier I had this option infer schema set. Now I've got schema and I pass in a specific variable that defines the schema. If you go look at the docs, you'll see there's other ways to do like a string that defines the schema. So feel free to kind of take a look and see what you like best. But ultimately, this is kind of the most base way of doing it within Apache Spark. So it's good to know that it's there. And you might find yourself exploring that quite a bit more, especially when you get into streaming off of something like Kafka, where you need to know the schema in order to unpack the data correctly. It becomes more helpful there. There is also a bit of an overhead with inferring the schema because it has to read some data first to infer the schema. So if you're going for performance, then defining the schema upfront can help. It just depends on, how much performance you're trying to get, how big your data is, that kind of thing. So that's it on the reads. I hope that was a quick enough overview to not put you all to sleep. But if you did fall asleep, wake up. We're going to look at writes pretty quickly here, and that'll be it for this session. So here I have my notebook with sample writes. What we're going to start with is by creating a data frame here. And so I just created some list items within Python and created a data frame off that, right? So anytime I do a write, it's going to be 4 rows, each of them with 2 columns. Columns are named item name and value. So it's easy to copy this code and use it if you want. Just know that the list of list here in sample data is how we define our data set, and then the column names list above is how we give those names. Once that's defined, I have the same types of protocols. A lot of the same types of authentication setup should cover your writes as well. First, I'll write to Delta because most of our writes, at least my recommendations are to write to Delta Lake a lot when you're working with Apache Spark. You'll have your data frame defined in your code, and you're going to call write. You're going to call a format of some type of data format. In this case, Delta isn't the name. And then I call save. There's additional things that you'll see start to pop up, like mode of overwrite will start to show up in some of these. With Delta, you can start setting additional properties on that table. In addition, how about at the end, I'll show how do we save it as a table instead of a file. Okay, so we also have the need to save a CSV sometimes. And so if you're going to do that, it's fairly straightforward. Again, there's quite a few options with CSV that are worth looking into, but if you want to do a traditional comma-separated file, you want to specify whether or not the headers should be included in that file, and then do CSV and put in a path there. Again, I'm using Databricks file system, just the kind of built-in cloud storage that's connected to this community workspace I've got in order to write everything. I want to call out real quick that Databricks file system is accessible to everything within that same workspace. And so you wouldn't really want to be saving your data here. Typically, you're usually going to lock that down a little bit differently. And you also want to make sure if you ever decide to delete this Databricks workspace, you don't lose that data. So what that means is if I'm in Azure, I'm going to be saving that data to Azure Data Lake Storage, maybe OneLake, which is Azure Data Lake Storage under the covers from what I understand. If you're in AWS, you're saving it to S3 most likely. And if you're in Google Cloud, there's just Google Cloud Storage there for you. Now, you don't always have to save it to files, of course. You can make decisions about saving to other databases or data warehouse systems, which is kind of in parallel to the reads we showed, as you can also write to most of these systems that we looked at. Here's Parquet. It looks very similar to the pattern we've been following, dataframe.write. In this case, I added the mode of overwrite, and then I can call Parquet and give it the path there. I also want to mention that if I was going to partition this data, I can do a partition by statement and add in fields here. So partition by is something that you can define in the write statement, and that's typically what I would expect to see if you're going to partition your data. Let's talk about writing to databases then. I've kind of covered the idea behind all of this, but we're going to use the same type of write commands, the JDBC format, pass in our values, and choose save. And then it's going to save to whatever table name I used right here, in this case, items test. Again, this doesn't work on the latest versions of Apache Spark, but if you're 3.1 or something older, you might want to use with Azure SQL databases, you might want to use this special format rather than JDBC. And as you work with different databases, you can always kind of go do a search at what people recommend. JDBC is used pretty often though, even though there's other formats that can kind of come in and sometimes work with the different options and different performance results. If I'm writing to Snowflake, the same types of settings I did to read need to be there. I've done my options the exact same way we read in earlier and chosen to save it to a table called items test, and that will save to my table. That's a wrap on how to read and write within Apache Spark. I hope that was a good next step for you. I expect us to look at transforming more of the transformations and some of the more concepts that you're going to do between the reading and the writing of data when we continue on this series. So not sure how soon that video will be out, but definitely take a look for it and subscribe to this channel to know about that and to stay up to date when I get around to releasing some videos and thoughts on some of the newer technology advancements that are coming along in the lakehouse space. All right. See you next time.